Hey everyone, thanks for spending your evening here with me and us. It's really a privilege and an honor to have your time. And so today, I want to spend some time talking about what we do at TRM, which is we build software to fight crime. Who here has either been personally or knows a friend or a family member that's been impacted by some sort of crime, whether it's theft, ransomware, scams, yeah? The crime story, unfortunately, is pervasive, and probably, more than 7 out of 10 Americans either have been directly or know someone who have been impacted by criminal activity. And so we're trying to build software to help fight that at scale, and we'll talk a little bit about how we do so. We'll start with a trivia question. Anyone recognize any of these faces?
Pablo Escobar.
Pablo Escobar, okay. You see the guy in the middle. I heard Bernie Madoff. Someone said Bernie? Madoff. Okay, Madoff. He's the guy on the right with the cigar. Who's the one on the far left?
Bonnie and Clyde.
Bonnie and Clyde. All right, you guys know your criminals well. Well, the one thing I want to highlight about each of these criminals that have captured the popular imagination is they're all people. Right? They're all individuals. And our technology for fighting crime has been built around people. You had fingerprints in the 1800s. You had CCTVs in the 60s. You had DNA forensics in the 80s. And then, we launched and pioneered crypto forensics in 2018. But everything we just talked about is built around humans. It's about humans transacting. It's about humans, defrauding. But what's changing in our universe is that the majority of crime that's now going to be conducted is actually no longer by humans. It's actually going to be by agents. So if you think about, the kinds of criminal activity that we have, how many ransomware hackers do you think there are in the world? How many ransomware hackers do you guys think are in the world? 1 million, 4,000? Okay, big range. Take the over-under on that. There are probably less than 5,000 people that are hardcore ransomware actors. And so, historically, we build systems and processes to deal with that human scale. With AI, and some of you have started to maybe read the news on, that 5,000 ransomware creators now have 1 million agents operating on their behalf, surveilling networks, penetrating 24/7, probing to see if there's any vulnerabilities. Initial access brokers that are scanning logs all the time, probing for the 1 minute in which your defenses are down. And so the scale of crime has fundamentally changed. The unit of scale has shifted from humans to GPUs. If you're a criminal compound in Southeast Asia that's trying to scam victims, it's a terrible tragedy where you actually basically have human labor that's forced into scamming people on Telegram and WhatsApp and your text messages. Who's gotten the text what's up? Hey, the contact, I don't know, I think I didn't save your contact, right? These are basically people internationally that are basically enslaved, for lack of a better word, to conduct this kind of activity. Now, those same compounds no longer need humans. They have an AI agent working 24/7, scanning your LinkedIn profile, your Twitter profile, your TikTok profile, and knows everything about you, and is going to create the most compelling story about why you should fall in love with them or why this investment is so great. So the scale of crime, the unit of scale, has shifted from humans to agents. But our public institutions continue to scale with humans. Our public institutions are fundamentally built around cops, right? Law enforcement officials. You need people to solve crime. And so the challenge with that is that you can't solve a problem at machine scale with human scale solutions. And so at TRM, we're basically building AI solutions to help our law enforcement agencies and crime fighters meet the moment of AI scale crime. Some of the things that we do across the world, like the types of threat actors that we deal with, we do ransomware payments, cartel money laundering. We look at how terror groups in West Africa and the Middle East fund their activities. We look at how North Korea funds its nuclear operations. We look at sanctions evasions in the Russia-Ukraine war. Basically, every major geopolitical conflict, we're helping bring our capabilities to bear and our data and our technology to help fulfill our mission as a company, which is to build a safer world. So this is an example of the product that we built and what we're going to spend some time today talking about, which is allowing our investigators to investigate at the speed of thought. And so we're going to spend some time talking about our AI agent that allows investigators to ask questions that previously would have taken tens of individual investigators, weeks or months of time, and solve it in minutes or hours. We just had just before I came here, we had a customer send us a note, and they were like, this is a 3-letter agency, and they were like, just got 2 investigations done before lunch, have a 3rd one on the way, investigating freedom of navigation in the Middle East, right? And so you guys can imagine what they're working on. But that allows them to reach a level of scale that previously they were not able to do because they would have had to click around and spend hours trying to get the signal from the noise, and we allowed them to operate at the tempo and pace and scale of the threat they're facing. Okay, so enough talk. Let's take a look at what this is in action. So I'm going to try give a quick demo. So here is what an investigator may come across. So imagine you're an FBI agent, and you may come across this address because you've collected some signals intelligence. In this case, it happens to be a crypto address. So we'll just start with this crypto example. And we're going to start to say, hey, what's going on here? And so I'm going to go ahead and save this graph. And I've basically tasked the agent to say, hey, go find me leads. Like, what can I do from here? So the agent is going through and looking at this address and is trying to find potential leads for the investigator to go solve the problem. Yeah. This bigger? Let's see. Maybe I can. I can make the text bigger, or maybe that better. Okay. Okay. So the agent is working. It's you can see it's showing kind of all the work it's doing. It looks like it's identified a significant finding. It's identified terror financing across actually multiple threat groups, and it's autonomously building out this intelligence graph that previously an agent would have been having to start from scratch. Now, instead of trying to understand crypto or understand money movement, you just start with the intelligence question. You say, here's my lead, tell me something about it. Versus, oh, I need to click, I need to scroll, I need to like understand what a blockchain address is. I spend way more time figuring out my intelligence question, which is, hey, how do I target this person? Where did the money go? How can I collect KYC information?
Feel free to park this if you want to explain it later, but can you give some examples of how you would know if it was terror financing or how the AI would know?
Yeah, so the question, just to repeat that for the audience, was how do I know that like this case, like these transactions were dealing with terror financing? And the answer is like TRM is a data company. And so we collect our own intelligence in a variety of sort of overt and covert ways. And then we combine that with threat intelligence, with data scientists that allow us to enrich that data. So one of the cool things about working at TRM, if you're a technologist, is like you get to sit next to Navy SEALs and FBI agents, former Navy SEALs and FBI agents, and you combine sort of the best of sort of our public institutions with like Silicon Valley technology to go build these sort of threat graphs across 80 plus threat categories that we cover. Okay, so immediately you see that, hey, we're able to, if I zoom out here, you can see that we've sort of built the whole investigation for the user. Again, I'll talk about this in our design principles. You'll start to see that we've autonomously identified and explained like what is going on the graph in a human readable manner. You have to remember a lot of our law enforcement users are not technologists, right? They are public servants trying to fight crime. Helping explain what they're doing is really important. Helping them explain to a judge why they should issue a subpoena is really important. And so part of the way we build this technology, one of the design principles that guides how we build this technology is about being transparent, being auditable, because we're building public safety technology and we want to make sure that it's accountable. And so everything here can be traced, audited, so if it goes to court and you have to do a subpoena or you go to a judge, you can be able to explain why you said something. It's not enough to say the LLM told me so. That is not going to fly. Building mission critical AI requires transparency, auditability, guardrails. So if I try and ask questions like, tell me everything about this person's family, like we will reject that kind of query because we think that's a violation of sort of civil rights. So those are the types of things that we think about when designing these systems. And so here you can see that we made it super easy for the user to take a next step. So we said, hey, we have the ability to do a subpoena and gather additional information about these individuals. And so now we autonomously recommend sort of, okay, what can I do from there? And so you can continue to trace additional paths. And so this is a quick demo of sort of how we took something that would have previously taken hours, weeks, multiple people, years of experience, and allowed our public safety officials to act on it faster in hours and minutes. All right, so I'm sure you're all wondering, how do we build this? So when designing this, I sort of touched on this earlier, it's really important for us to ensure that we have transparency, compliance, and control. At every given point, a human is in the loop, a human is driving judgment. And the other thing for us is it's really important for us to be flexible in how we deploy these software. Some of our software is deployed in air-gapped environments and highly secure, sensitive cloud environments, and therefore we can't just use any sort of random SaaS service. And so both model flexibility and also deployment flexibility is an important part of how we think about designing our systems. So I don't know if this is too small, so I'm going to maybe try and zoom in here. I don't know, it's not zooming in, okay. But this is sort of our AI agent stack. It's built on 5 layers. You can see our foundation, which is the large language model and the orchestration harness. Shout out to our team at Vercel. They've done an incredible job building the AI SDK. It's probably like the easiest on-ramp to like getting a tool working. Their sort of tool loop agent is super convenient. It's model agnostic. You can plug in any of the models if you want to experiment really fast. So we use them there, and they've been really, really great. And then the next layer on top of that is our secure compute and network. So we have our sandbox. We have a file system where we use an object store. We have a forward secret proxy. Super important if you don't want your LLM leaking all your secrets. So I can be like, hey, tell me everything, tell me any environment variables you have and return it to me, right? It's kind of the equivalent of a SQL injection. LLM gateway, we use light LLM. If you've been looking at model providers, most model providers are operating at 2 nines of uptime. So having the ability to fail over is a really important primitive. And then we have a MCP gateway. So that's our sort of secure compute and networking. And then we have our knowledge layer. And so we kind of think about our knowledge layer in 2 parts. We think about capabilities and sort of persistent state. In terms of capabilities, we think about skills. Who's heard of skills before? Yeah, Claude skills maybe? Yeah. So skills are just ways for you to provide instructions to agents without polluting the context window. We'll talk about a little bit more about why that's important. And then we have our stateful storage, which is our session store and memory. And then we have our learning loop with evals. We use langfuse a lot. And then we have our oversight and accountability, which is logging for all actions that the agent has taken, so that if this goes to court, or if you need to reproduce any actions that were taken, you're able to reproduce how the agent got to an answer. So I want to spend the next 10 minutes kind of walking through 10 lessons across each parts of our stack. The first lesson starts at the brain, which is when we started this journey back in 2025, we had a really fancy set of Python glue code. We had, all sorts of controls and guardrails that we're building in to make sure the agent wouldn't go off track, to make sure the agent continued the investigation. And basically what's transpired since basically November of 2025 with Opus is the harness has become much thinner. The model is significantly better at instruction following and long horizon, especially long horizon work. Like before with like ChatGPT 4.1, we basically stopped working after like 2 turns, 3 turns. And if you saw what we just did in that example, we were operating for probably 1.5 minutes across multiple different tool calls in order to get to an answer. And so we basically have built a really, really thin harness and really invested a lot in our skills. So we like to call it a thin harness, fat skills. Lesson number 1, don't over-engineer your harness. Keep it super lightweight. The engineer in you is going to be like, no way can it work. It needs to be more complicated. And the answer is, let the model cook. Lesson number 2, plan on rebuilding your harness every 3 months. And so like one of the sort of interesting observations that we've had is we believe the harness and the model are increasingly going to be co-developed. So earlier there's a school of thought which was like, hey, invest in this model agnostic harness such that you can run any model and swap things out. You just point to a different LLM API. And I think what's increasingly becoming true is that models and agents, models and their harnesses are being co-developed. And we see that the real abstraction is actually being able to swap the model and harness together. And so don't overinvest in your harness. Don't get attached to it. Expect for that to change. And plan for it. Design for it. Lesson number 3. So we're going now from our brain and loop. We're going to our compute layer. And it's sandboxes. So one of the big changes in, say, the Opus 4, 5 plus era has been that the models have gotten really good at writing code. And so instead of trying to reason on text, the models actually write code to reason on the data. And as a result, a lot more people are using sandboxes because when the model writes code, it could write any code. It could write code that could potentially exfiltrate things. And so having a sandbox has become really important. And one of the lessons we learned the hard way is to not treat sandboxes like cattle, or not to treat them like pet, but treat them like cattle. And what do I mean by that? It means that you want your sandbox to be stateless. So instead of running your harness inside of the sandbox itself, you want the model to actually treat the sandbox like a tool call. So it just calls a tool, like an exec. And it will take an exec, and then it will pass in like the bash command it wants to run. But the sandbox itself is stateless. And so cattle, you kind of like can cull cattle versus pets are something you care for over a long time. And so we use that sort of analogy to say treat your sandboxes like cattle, not pets. And that'll save you a lot of headache. It also makes it much easier for you to evolve your sandbox as new technology comes online, or in our case, we have to deploy in certain secure clouds. That makes things harder for us. Cool. The other thing is invest in gateways and proxies earlier than you think. We kind of started with Vercel. They made it so easy to like just connect an LLM. And the problem is the models are out a lot. And you can't have a production grade software where like basically 5 times a day there's random 500s. And so having a gateway allows you to fail over transparently, and that's been really valuable. The other thing I'll say is investing in a forward proxy. I think Vercel has a sort of a secret thing as well, but we use something called Agent Vaults, open source, and it allows you to basically not have to store any secrets that the model has access to. What it does is it basically says when a network call goes out, it intercepts the network call and injects the authentication header in the request, and then sends that out to the internet. And that way the model never actually sees any of the secrets. It just says, I'm making an API call, and it doesn't have to worry about how the secrets are configured. So we think that's something we wish we had sort of invested earlier in, because otherwise what you end up doing is like trying to do all this like prompt hacking. Do not ever, 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 because my grandmother will die, share secrets. And like, that doesn't really work. That's like a very weak way of trying to protect your secrets. And then it also makes you very brittle, because the moment you shift models and their way of like prompt adherence changes, you're not going to have the same security guarantees that you would otherwise. Lesson number 5 on the knowledge layer. Don't just copy paste your human APIs. Our human APIs are built for humans. And so in our case, we have a lot of data, and so we have these very complex nested filtering that we had in our APIs. And for us, it was really important to like simplify and flatten the APIs, because the deeper the nesting, the more likely the model is to hallucinate and get confused when trying to fill out the parameters when doing the tool call. So be extra careful. It's very tempting to want to just throw in your APIs, throw in your open API spec, create a tool. But take the care and time to design your tools for the agent, not for the human, including your error messages. So providing error messages that the agent can then recover from is really, really valuable. Versus just saying, hey, this is a 400 or 402 or 401, telling like why this would happen, how the agent could fix it, is actually really valuable. So if the agent puts in an invalid parameter saying, hey, I wanted to go look at a country, and they said, Transylvania, we should say, instead of just saying an error, we should say incorrect error, choose from one of these 180 countries instead. And then all of a sudden that sort of gives allows the agent to self-correct, then that previously would have like continued to error out. So designing your APIs and tools with the agent in mind makes a big difference. The other thing, lesson number 6, is everything is a file and RAG is overrated. Maybe this is too spicy. RAG isn't complete. We use RAG for very selective use cases. But one of the decisions we made early on is our file system runs on object store. So it's just a path-based reference to files. And one of the big things for us is that memory is just a file. Skills are just a file. even our API calls, right, our tool use, we write them to files. Like our working memory is just a file. Everything is a file. And so oftentimes I see people saying we need to RAG this and have this whole pipeline. You add a lot of complexity with RAG for very little benefit. And especially as the models have gotten really good at computer use and tool use and bash and grep and sed and awk scripting, it's actually been a really powerful way to simplify your stack. Lesson number 7, use auto research so hill climb your skill files. So when we first started building this, it's a funny story. One of our engineers on our team, his name is Manish, we were saying, okay, how do we start like training the agent to think like an investigator? And we did the most obvious thing, which is we actually went to Slack and we asked Claude to go mine all of our Slack channels and look for all of the ways in which our investigators work. And so our first pass was actually using Claude to mine our Slack for our investigators that work at TRM and get their best of knowledge. And it kind of worked. It got us to phase 1, got us a demo. And then we needed to improve it. So we said, okay, next step, hey, Claude, go to all of the best practices that you know on the internet for skills and look at what my skill files are, identify the gaps, and fix it. Another bump in performance. Then we said, okay, you know what? Let's look at our actual, let's connect our tracing and monitoring to the agent itself, so that the agent can look at like all the failure modes that happen in our telemetry on LangFuse and ask it to reflect on the failure and say, how can it fix the skills? And so then we create like this auto research loop where we're autonomously improving our skills just based on failures that we're seeing in the logs. And so start simple, do the like dumb thing, use the LLM to make your skills really great, and then connect it to a model loop so it can auto-improve on itself. This is sort of a corollary, which is investing in observability and experimentation early. A lot of times people think of that as like an afterthought. We learned that the hard way. LangFuse is what we use because it can deploy in other environments, but highly recommend spending time. And I think a lot of times people want to use the existing logging provider, and some of them are starting to catch up. But there's a lot of value in being able to like look at the trace data for tools in a very specific UI that makes it easier for like the humans to also interact with the data. This is a really important one, lesson number 9 on the learning loop, which is decoupling your agent loop from the transport. So a lot of times, the mistake we made when we first started is that we connect, our agent loop was very tightly coupled to the transport, which means that the WebSocket that triggered the agent loop was tightly coupled to like your front end, to the transport, which is the WebSocket, was tightly coupled to the agent loop. But that made it really hard for us to be able to run evals like in CI/CD, run things out of band, do reproducibility. And so this idea of like a headless agent, where you've sort of decoupled the transport from the actual agent loop, skills, sandbox execution is really, really important, because that allows you to be able to actually run some of these sort of learning loops in your CI/CD and make that as part of your normal hill climbing operation. And finally, I'd say on feedback, a lot of times people are like, oh, you should have a plus button and like give them a thumbs up button. Turns out no one actually likes filling out the thumbs up button. Even if you have it on the UI, like I think less than 10% of people actually like click it. Even like our internal users, we have to like ask them like multiple times, like please give us feedback. And so I think what's been really powerful is actually looking at implicit feedback. So implicit feedback is like if I really liked a restaurant I went to, right? I may not leave a review, but I may share it with a friend. The fact that I took the care to share it with someone else tells me something, that there was some unit of value. And so using these what we call implicit signals to then identify what were like positive events and negative events allows you to build a bigger corpus of data for your continuous learning feedback loop. Don't hope that your users will give you the thumbs up. You'll either get a very, very biased sample, and not only will you get a very biased sample, but you'll also get a very small sample. So those are the 10 things, 10 lessons we have learned in building our AI agents that fight crime. Happy to chat more about it. Where we're going next, we're looking to add more, doing more in memory. We're looking to improve latency. So if you saw one of the things that we're looking to improve, like one of the things we want to improve is our latency and how can we use cheaper models to run faster. And so there's something new that Anthropic recently announced around the advisor pattern. That's something that we want to experiment with to drive down latency and cost. And then allowing it to be more multiplayer. So how do we allow people to share knowledge graphs, share their sort of memory across investigations and within their organization. So cool. So that's what we do at TRM. We build a safer world, and we'll take questions later. So thank you.
How's everyone doing? I want to take a second and appreciate the beautiful view we got. It's pretty badass. Okay, so nice little icebreaker. My name is Melky. I'm a staff engineer at Vercel. Today I'm going to talk to you guys about AI and agents at Vercel. And what does that mean? It's basically going to be like how Vercel views this moving forward. I think we saw from Rahul's presentation how they're using it from the infra perspective and from a first primitive perspective. I want to tell you guys how we're thinking about it from the inside, how we're building them, and what that means moving forward. And if anyone is on X, connect with me, please. I love just talking, shop, meeting people, connecting. So I'm looking forward to meeting a bunch of you after as well, if anyone has any questions. So building new agents brings lots of new complexity. It's getting simpler, of course, but with agents and security and all these other things, there's a lot of kind of domains engineers, teams have to think of. So there's tool calling, right? I think in the first like dinosaur age of agents, everyone's thinking like, okay, can it call the internet and call an MCP? And now we're looking that there's way more ways to re-enable an agent to be way better, way stronger, and more capable of different tool calls. And it really matters on the hardness too, right? Like Claude Code, Codex, Open Code, FX, coming soon. There's lots of different harnesses and they all kind of deal with tool calls differently. There's agent access, right? This is a key one. If you are building something and you give your agent access to your user token or your auth token, is it you or is it the agent? If it messes up, is it you or is it the agent's fault, right? So there's this layer of agent access that a lot of people are still kind of figuring out. Do you mint new agent tokens that have scope permissions just for the agent? So that's one that's always fun. There's durable compute, of course. Secure code execution, I think super hot right now. Sandboxes. Everyone loves sandboxes. Everyone's making sandboxes. So that's always going to be something very important. Scalability, reliability, and one that I still think is actually very underrated is observability. I think this is still kind of an untapped domain in the agent space. It's really observing how well the agent's performing, what it's doing, how can you monitor it. Obviously we have evals, but I think like in prod, what is it doing? How is it reliable? So that's like another domain for agents and the complexity it brings. And so at Vercel, when we first kind of wanted to pivot to like this agent cloud, right? We came up with a lot of great, and we're still coming up with a lot of great primitives and tools, right? And some of them were talked about, some we can talk right now. So obviously there's the AI SDK. This is super powerful because of how simple it is. Like Rahul said, it is a very easy way to get your app, web app, any kind of application communicating with LLMs very quickly. And when you talk about AI SDK, you also talk about AI gateway. One key, any inference you want. Super, convenient. It's typically like one line of code as well in the AI SDK. So they go hand in hand typically. And we have fluid compute. So this is cool. If you have your LLM running or your agent running, you don't want to be charged for when there's no IO or anything. So you only get charged when there's actual processing going on. So that's fluid compute. Sandboxes, Vercel launched our own sandboxes. They're one of the fastest sandboxes in the market. We're competing with Daytona and a bunch of other sandbox providers, but ours is actually one of the faster ones. And just show of hands, who's had the chance to actually just play around with the Vercel sandbox? one, maybe a few. So at the, try it out. It's free. Just play with it. It's super quick. Benchmark it if you're in sandboxes and you want to look at some other ones. I think Vercel Sandbox offers a really good option for people. Workflows, we just did GA. Workflows super hot. It's ripping. You can make any function durable. You can give it, just context to pass down. And it's a really interesting way to kind of keep a replay session of an agent and kind of go back to it. And then there's chat SDK. So, if you want to continue your agent and communicate with Discord, Telegram, WhatsApp, chat SDK is definitely a tool for you. So all of these, right? So those are kind of like the agent stack, if you will, right? If you want to build an agent, that's kind of some of the tools you'd use. Whether it's from Vercel or not, we dubbed them the agent stack. And this worked really, really well. However, what we've seen is kind of this new pivot when it comes to agents, and that's not really the infrastructure, even though it's still super important, but this new shift that we've had at Vercel and Vercel Labs is like primitives for the agent, right? Like people are going to build sandboxes, that's great, that's going to solve one problem, but the problem that I'm personally interested in is how can I make my agent better than someone else's agent, than another session's agent, right? And the answer we really came to is like primitives. And we're still really, I'll be honest, we're still dissecting what makes a good primitive. And I think the first one that really came up was like MCPs, right? Like I said earlier, MCPs really provided like this amplifier of agents. And then we discovered that CLIs, agents love CLIs, right? So now CLIs are kind of this great first primitive for agents. But we also create skills. And skills is kind of like the way I think about it. Skills is like a recipe, right? If you have like a cookbook, a skill is one individual recipe. It teaches you how to make like a dumpling or a hot dog or a soup. And your agent gets really, really good at making a dumpling, a hot dog, or a soup. And we have a lot of different skills. We've passed a lot of different thresholds. We've seen these really, really work, and they're powerful at improving the agent. You can see here's an example, Vercel React best practices. It has this is outdated as hell, actually. I think it's near 350 or 400 weekly installs. They're super easy to just install. You can do it on per project basis or globally across your computer. And we've also, like I said earlier, the CLI is also a great primitive. And CLIs are just really powerful agents, right? It says here, it should be everything an agent needs. And I truly kind of believe that. A really good CLI should be all that is an agent needs. If it has access to a CLI, it should know how to deploy, how to read logs, how to debug, how to do X, Y, Z, if the Vercel CLI is built for this. And that's exactly what we've done. The CLI originally was built for humans. You want a human to read the help commands. You want a human to read the debug code. You want to do all that. And that was kind of our customer zero. The new customer zero is agents. We're building for agents first. And there's a clear difference there. First of all, how it reads APIs, how it gets the spec from Open API. All of these different things are significantly different than when an agent reads it versus when a human reads it. And so we've done a lot of work on revamping the CLI to be a lot more agent first. And we've actually also included skills as part of that in the CLI. And the other thing that I'm biased as hell because I wrote it, but the Vercel plugin is, we discovered another good primitive, and just plugins in general. Again, show of hands, who's used any plugin on any of their harnesses? Again, a few people, okay, more than the previous question, yeah. So plugins we've actually discovered to be really good, but they kind of have this clear double-edged sword case right now because I think they're still new. A lot of people see that plugins are consuming a lot of tokens, which is true. They do consume more tokens if they're not developed correctly. They could really sway your agent if you use a particular plugin. So we're still kind of calibrating what plugins mean, but what we've fully discovered is how good they are in truly just working with existing agents. And if I continue the previous analogy with a cookbook and a recipe, if a skill is an individual recipe, then this is like a cookbook. This has a collection of different recipes that the agent harness can tap into, explore, use, and see if it needs to, see what skills it needs for what particular purpose. So kind of like an all-in-one housing. And right now we support the Vercel plugin for Claude Code, Cursor, Codex, Copilot and Grok. So it's growing. And I think that there's a lot of new companies building plugins like open code. They're actually releasing like their own whole plugin ecosystem. So I truly think plugins aren't going to go away anytime soon. And some stats, this is again a little bit outdated, but what this graph shows is number of VC deploys or Vercel deploy commands using the CLI of a human versus an agent. And so you can see that at this time, it was about 17% of all deployments made on Vercel were by an agent. That number is closer to like 35 now. So what this tells us is like agents are running majority of items now on behalf of the human. And so again, this is why we want to build for agents first. And then another quick stat. So for plugins, you can see that there's been kind of like a ramp up. We're getting about 7.5 thousand installs per day, and we have about 118,000 daily active users of a plugin. That's across all the harnesses. So again, and this number just keeps increasing, and I do think like plugins are a very worth investment for harnesses. But honestly, bias aside, I think there's still opportunity to discover like the next level of primitive, right? Like we're still at skills, MCP, plugin. I am curious personally to know what the next level is, what it could be. So that's kind of it. That was like a light kind of description. I'll briefly show you like a quick demo. It might be kind of hard to see, but basically I'll just show you a version of Grok with the plugin and a version of Grok without the plugin. So it'll be quick. So we'll start with the left one. You can see here, like, hello. I'll just do a quick. Sure. Is that a bit better? Cool. So I'm just gonna create one quick HTML file. It's gonna completely, like there's nothing in it. You just let me create it. I'll go ahead and go to Grok. And the reason why I'm using Grok is because everyone demos with Claude Code and Codex and shit. So I decided to do Grok, like whatever. It's new, it's fun. And you can see here, you can see all the different plugins available on Grok. And here we have the Vercel plugin, it's installed, right? And all I'm going to ask it is a very simple prompt. Please deploy this HTML file. So that's it. I'm just gonna run it like that's it. I didn't do anything before. There's no like folder or nothing in there. It's gonna run through it. Because we zoomed in, I don't think we can see, but it's pulling in a lot of skills. So you can see here the Vercel CLI skill. It's pulling all the different skills, right? You don't really need me to showcase how this fully works. The point is, if you go from a naked Grok, which I'll show you in this pane right here, you give this exact same command, it's gonna flop. It's gonna be like, what do you want me to do? Do you want me to like locally run it? And it's gonna do all this nonsense. But with the Vercel plugin, it's gonna be a lot more closer to what you want on actually deploying to Vercel. So here it wants me to log in. So yeah, I can do that, but that's not really the point. Here I'm gonna just show you the second version without the plugin installed. So here, there's no HTML file, so go touch index.html, and I'll actually do something real quick just to uninstall the plugin. Oops, sorry. Let's go install. It's a Vercel plugin. I'm just gonna uninstall it. The reason why I'm doing this is because Grok doesn't have its own marketplace yet, so it kind of just sneaks and uses the plugins from Claude Code, which I find kind of funny. But we go here for Grok. We'll do plugin. Again, Vercel. So nothing here is going to confirm this is like a naked Grok, and then I say the same prompt. It was like, please deploy this HTML file. Now, if I'm lucky, it should mess up. But if it's a demo and demo occurs, who knows what could happen, but we'll see. Yeah, okay, perfect. So there you go. So here it's just saying, can I help you deploy it? It has content, so it wants me to do a local server, or it's kind of coming up with some sort of solution to deploying it. Versus the one on the left is very clearly like, I'll launch it with Vercel. All I need to do is log in. So there's a very clear stark difference between the bias, I guess, or the influence of your agent harness with the plugin. And this is a very dumb example. I was going to show you something way more, but I found it just like a little too much, where it's like create a chatbot app and it shows you the differences. The current agents are pretty good at picking like Next.js for a web app, but where they kind of mess up is like storage, right? A lot of them still refer to like Vercel KV, which is deprecated. We want Neon Postgres in the marketplace, Clerk via the marketplace. So all these different things, the plugin allows you to just handle a lot easier and a lot more seamlessly than if you're just kind of going at a naked agent and then to kind of convince it, wait, no, instead, can you deploy it on Vercel? And it's like, wait, okay, sure, let me deploy it. Do you have the Vercel CLI? That's to do all this. So spending a lot more. And yeah, that's basically it. That's the demo. And thanks for listening.